Let's look at the second derivatives. Second derivatives tell you the concavity, so whether the graph is concave up, making a U shape, or concave down, like an upside down U shape. Okay, so f double prime is positive, then you make this up U shape, and then when f double prime is negative, it's upside down U shape, kind of, right? So this is what we talked about in day one. So maximum min occurs when f prime is 0. So let's look at this point when this is a local min right here in the original graph f, and if you look at down here, f prime is 0. Okay, this is f prime, f double prime, by the way. Okay, here's a local max there. F prime is 0. Okay, and local min, again, go straight down, f prime is 0. Right? So max or min, f prime is 0, and maximum happens when f prime changes sign from positive to negative. So here is a maximum. You notice that the graph is going up, increasing here to the left of the max, and then decreasing to the right of it. So f prime is positive to the left and negative to the right. Okay, that's how you know from f prime graph that you have a local max. And minimum happens when f prime changes sign from negative to positive. The graph goes down and then up. So here, graph is going down and then up, right? So f prime is negative and then goes through 0, and it's positive to the right side, right? So that is the relationship between f prime, the first derivative, and the local max and min. Okay, now let's look at the second derivative. All right, so if you get rid of these first. All right, so let's look at this. When is my second derivative positive? That's when my graph is concave up, right? So here, somewhere in this area, I should be concave up, right? So let's look at here. And it's going straight up. All right, so when f double prime is 0, that's exactly where the point of inflection could happen, right? It's a possible point of inflection. Just because your f double prime is 0, it doesn't mean that you're going to have a point of inflection. You have to check to make sure the concavity changes, because the definition of point of inflection is f double prime changes sign from positive to negative or negative to positive. Okay, so if you look at here, f double prime is going from positive to negative. If you look at the graph, the f of x, here is concave up, and then to the right of this point is concave down, right? There's another point like that right here. Okay, let's go straight up. Right there, that's when the concavity changes. Right here is concave down, and here concave up, and that's exactly where the point of inflection happens. That's when the concavity changes, and here. Now, I was talking about the original graph and the second derivative, and I drew a line straight up. What did you notice about f prime graph? The point of inflection happens at the changing point, like or local max and min of f prime, right? That's when the point of inflection happens. So this f prime can tell you a lot about the original graph, right? You can figure out that these points right here, this is going to be, without even looking at the original graph, I know this is going to be a local min, because at this point f prime is 0, and here is negative and positive going down and up. Here I know that you're going to have a local max because f prime is 0 and f prime changes from positive to negative, so graph went up and down. And here I'm going to have a local min because the graph changed from down to up, right? And at x equals this value right here, I have a point of inflection, right? You can compare that to f double prime, and at a local min of f prime, you have another point of inflection. So just by looking at this, you can figure out the max and min and a point of inflection of the original f graph. And here is a chart. I'm going to organize it. When f prime is 0, this is your x-intercept. Okay, and this is not very interesting. Just that's when f is the graph is above the x-axis. This is when graph is below the f-axis. So f of x is greater than 0 here. F of x is less than 0. That just means the graph is below the x-axis. Here, graph is above the x-axis. Right? When f prime of x is equal to 0, that means this is a critical number. This x value is a critical number. Okay, and I have a possible max or a min. Okay, it's not guaranteed that you're going to have a max or a min, but that's a good place to look. Okay, here when f prime is greater than 0, your f is increasing. When f prime of x is less than 0, f is decreasing. Okay, when f double prime is equal to 0, that's a possible point of inflection. Okay, if it doesn't change, if the to the left and to the right of this point, the concavity doesn't change, then that's not a point of inflection, right? They have to change from concave up and down or down to up. If your f double prime is positive, then the f is concave up, right? Concave up. And f double prime of x is negative, then it's concave down. So your graph here looks like something like that, and here it looks like that.